2, 1.
Hit it.
Experience 24 hours of head-to-head AWS sessions from around the world.
Mic check, 1, 2.
Jaws PANKRATION 2021. Up till down.
Hi, my name is Gabe. In the next 15 minutes, I'm going to teach you the basics of building and deploying your own serverless chatbot on AWS. First, let's discuss why chatbots are great. Chat is a natural and on-demand way to interact with a business. If the chat is powered by a bot, it can be available 24 hours a day, 7 days a week, 365 days a year. Chat interfaces are accessible from a variety of devices, and they're becoming more and more effective at meeting the needs of customers around the world for many use cases. For example, here are a few of the most common use cases we see for supporting customers with conversational interfaces. If you have a contact center, you can offer customers the ability to conduct self-service. This can give your customers a chance to resolve their problems on their own and reduce your call volume. Or for cases which cannot be completely handled with self-service, a chatbot can help in collecting all of the required information before connecting a customer with a support agent. You may also have encountered a case where chatbots are made to help provide information for a large group of users, usually with some kind of intelligent search capability. We're even seeing some companies develop internal chatbots to streamline enterprise employee activity and workflows. At AWS, each of our services is built to meet the needs of our customers. In 2017, we released the first version of Amazon Lex, a service to support our customers with creating, testing, and deploying their own chatbots. Amazon Lex is a service for building conversational interfaces into any application using voice and text. It enables you to add sophisticated natural language chatbots to your applications. And it combines automatic speech recognition with natural language understanding to make this easy and powerful. Amazon Lex also lets you integrate with many other AWS services, including Amazon Connect for call center management, Amazon Kendra for enterprise search, and AWS Lambda for serverless computing. It also offers pre-built connections for popular messaging applications, including Slack, Twilio, Facebook Messenger, and more. But before we go any further, let me show you a demonstration of a simple chatbot built with Amazon Lex. Here, you can see me interact with a chatbot that will help me make a hotel reservation. When we get to the price of the hotel, please excuse it. I know it's too high. I'm using placeholder values just for demonstration purposes. So as you can see, the chatbot helps me with other tasks too, like reserving a car for my same trip. The bot can understand the context for the conversation and continue to ask for the necessary additional information rather than having me repeat myself. So I provide the final information, and not only did I book a car, but I also booked a hotel using one simple, easy chatbot. Chatbot, not jackpot. So many customers around the world use Amazon Lex today to power their chatbots, including all the companies you see here. I don't have time to talk about all of these use cases, but let me quickly share some nice details of one customer I think you have probably heard of. Dropbox's mission is to design a more enlightened way of working. They serve more than 600 million customers across 180 countries. They started as just a storage and file sharing tool, but they're now a full collaboration platform. Dropbox wanted a way to create customer support chatbot that could scale and work as effectively as one powered by a human support agent. They chose Amazon Lex to build a text-based chatbot because it was easy to integrate with Dropbox products and other AWS products. Thanks to Amazon Lex's rich feature set and their security, Dropbox was able to launch their chatbot in October of 2019, first just handling frequently asked questions. Over time, they expanded supported topics to solve even more issues for customers quickly. When the chatbot was first launched, they were able to solve 30% of their issues. Now the number has increased to over 85%. So I hope I've shown you enough to get you interested in learning more about Amazon Lex. So let me show you how easy it is to get started. There are 5 key steps to prepare and build your first Amazon Lex chatbot. First, you're going to script. Write your sample dialogues that illustrate the ideal conversation flow. Next, you want to design by mapping out the customer experience and translating your scripts into the components for your bot by identifying sample phrases. Then you want to build, create a bot, configure the intents, and define sample utterances and slot values that you want to use. Then you're going to test by trying out the bot in the console to ensure it's working as expected. Finally, you will deploy by publishing your bot to your end users and then analyze their feedback to continue to iterate and make it better over time. At the highest level, a bot consists of 4 things. First is an intent, which a bot can have many of. These are the definitions of something the bot can do. In this case, the bot has an intent called book hotel, which I'm sure you can guess the purpose of because it's the same thing we saw in my demo. But how do we trigger it? An intent has a list of defined utterances. These are phrases that will trigger the bot. You don't have to match exactly because the Lex's natural language understanding will try to find a most appropriate intent to match a phrase. So how does the bot get all the info it needs, like city, date, number of nights, room type? It does this with slots. This is the information that an intent needs to define how to successfully fulfill itself. Slots are just placeholders. For example, for a date slot type, you can give an explicit date, or you can say something like Friday or next Monday, and the bot will understand your meaning. Eventually, the intent will have collected everything it needs, and it will ask you to confirm. Then it will actually call some code through an AWS Lambda function to do the work. Let me show you the same sample example, but this time in the AWS Management Console. Here's the Lex console homepage. And please excuse my English language settings here. I took these screenshots when I was doing it. But as you can see, I have two bots defined. Let me click the first one, which is a bot for Japanese language interactions for booking the hotel and car trip. Here, you can see the various parts that I covered a moment ago. On the top left, we have intents. These are the different things a person may want to do, like reserve a car or reserve a hotel. Here, we are looking at the intent for renting a car. Here is the same screen, but this time viewing the other intent that this example bot can handle, booking a hotel. Each intent lets us define the utterances, and these are how the bot matches intents with what the user says they want to do. Each intent has slots that the user is required to fulfill the intent. So here you can see them with all the pretty colors. Now, if you look carefully, you can notice that each slot has a type. And many of the ones listed here use built-in types like city, date, number. But we can also define our own custom slot types, such as the allowed values for the type of hotel room that we want the user to be able to reserve, like king, queen, twin bed, etc. Of course, we can customize the slot types with whatever values we want. Now, after a user interacts with our bot and has supplied all the information, we can pass the information to an AWS Lambda function to fulfill the intent. In this case, that probably means interacting with a hotel and a car reservation system to complete the transaction with the user's preferences. In addition to using Amazon Lambda to fulfill the intent, we can also optionally use Amazon Lambda to validate all the slot filling interactions before the intent is ready to be fulfilled. If we don't enable this, then Amazon Lex will do its own work to make sure the information the user is supplying for each intent is valid according to the defined slot types. If you enable the option to validate with the Lambda function, then you have much more control, but also you have the responsibility for doing that validation yourself. When your Lambda function gets involved for the validation or fulfillment, it gets a JSON document passed to it with the information that follows a particular schema. And your Lambda function just needs to return a similar JSON document so Amazon Lex knows what to do next. And you can see all the details of this in the Amazon Lex documentation. Finally, I want to recommend an open source project to you. If you would like to provide a web UI for your users to interact with Lex chatbots, definitely take a look at the Amazon Lex Web UI project. It supports both voice and text chat and the ability to switch from one mode to the other. And it works well on the desktop and in mobile browsers and is very configurable with JavaScript. If you would like to learn more, please visit the resources on this slide, specifically the Getting Started guide and the rest of the Amazon developer guide for Amazon Lex. We have 2 great tutorials available on GitHub, which you can see at these URLs. And finally, 3 great videos, an introduction to Lex from our training site, as well as detailed information on how to communicate with chatbots, also on our free training, and many other video resources are available, noted on our website.
1 minute left.
This concludes my introduction to serverless chatbots with Amazon Lex. I hope I got you excited and you can see how easy it is to get started. The demo you saw today for booking a hotel and a car is included in the Amazon Lex defaults, so it's very easy to get started with the same demo you saw me make today. Thanks very much, and I hope you have a rest of a great day and build on. Thank you.
Music's loud and I'm feeling alright. It's slow motion, but it's just you and I. Yet the burn makes you feel so alive. I'm living the moment, so you know it tonight. We're here now, let's party together. Tonight is forever. We're here now, let's party together. Tonight is forever. Let the rhythm move us, yeah baby, take it too far. You're at the center of my attention, yeah you got me so lost. I love the way that you move and how the lights keep up the groove. We're like in a movie.